Welcome back, recruits, to Phase 3 of AP Calculus Bootcamp. Today's operation covers advanced tactics and higher-order derivatives, encompassing Unit 3, Topics 3.5 through 3.6. Your clearance is verified for Recruit Eyes Only, so let's initiate Mission Go. Up to now, you've engaged clean targets, where standard power, product, and quotient rules apply seamlessly, like y equals x squared or y equals sine of x. However, you will encounter chaotic targets out in the field, such as y equals x squared times sine of 3x. Basic sequential rules are completely insufficient when faced with these combinations. You must determine if it requires a product rule, a chain rule, or both, which demands advanced selection protocols. This brings us to the rules of engagement and the outer shell protocol. When establishing a target lock on a complex function, you must respect the order of operations. If multiple rules apply, step back and let the outermost mathematical structure dictate your first move. In this diagnosis, the target is fundamentally a product, where the second component contains a chain. Your action plan is to execute the product rule first, and only deploy the chain rule when differentiating that second component. Next, we move into deep reconnaissance with higher-order derivatives. Think of the original function as level 0, or the surface. Executing the derivative protocol gives you level 1, the first derivative. The output of level 1 then becomes the raw material for level 2, giving you the second derivative. The key insight here is that the mechanics never change. You are simply running the exact same analytical machinery on newly extracted data. Threat identification is critical, so memorize this decryption key for notations. The AP exam uses prime notation and Leibniz notation interchangeably to make sure you understand both. You must recognize that f double prime of x and d squared y over dx squared represent the exact same objective. Pay special attention to the Leibniz notation for higher-order derivatives, noting the placement of the exponents on the operation in the numerator and on the variable in the denominator. You also need to understand the relational shift in our conceptual framing. A function relates to its first derivative exactly as the first derivative relates to the second derivative. This rate of change relationship is mathematically locked. Anything you know about how the first derivative relates to the original function perfectly applies to how the second derivative relates to the first. Be advised of a critical threat level. Don't drop the chain. Misidentifying the inner function, or forgetting to differentiate it entirely, is the #1 cause of mission failure on the AP exam. When taking the derivative of a composite function, if your missing intel leaves off the final piece of the equation, your answer is compromised. Adopt this standard operating procedure mantra. Physically say, times the derivative of what's inside, every single time you execute a composite protocol. Expect high-risk targets using variable camouflage. Do not get tripped up by letters. While a standard target uses clean x variables, you will see time or particle equations using t, or angular equations using theta. The AP exam will constantly swap variables to test structural understanding over blind memorization. Just recognize the variable swap, treat t or theta as the new x, and execute your normal protocols. Complete situational awareness requires multi-source intel. The AP exam rarely relies solely on clean analytic equations. You must be able to execute Phase 3 derivative rules, like the chain rule, using raw numerical data pulled straight from a table, or by extracting tangent slopes manually from a visual graph. Time for the after-action report and exam survival SOP. 1. Secure the outer shell. Let the outermost mathematical structure dictate your first strike. 2. Never drop the chain. Always multiply by the derivative of what's inside. 3. Translate the notation. Know your primes from your d's. 4. Triangulate intel. Practice your analytical rules on raw table data and visual graphs. You are now prepared for contextual applications. Status: dismissed. For more AP Calculus worked out free response question solutions, like and subscribe to get your FRQ on.